Let's learn how to calculate the length of an arc and the area of a sector of a circle. So first of all, let's look at this example. What is the shaded area? What's the amount of yellow area right there? So the area of a complete circle is pi r squared. So in this case, it would be 9 pi. And this is 90 degrees, which is 1/4 of the circle. So this area would be 9 over 4 pi, 1/4 of 9 pi. Okay, how about this one? Well, now our central angle is 120 degrees. So that is 1/3 of the whole circle, because 120 goes into 360 3 times. And so the area of the shaded part is going to be 1/3 of pi r squared, which is 25/3 pi. So let's generalize this. So what if I have just a random angle x degrees and a random radius r? Then the area of that sector is going to be however many degrees out of 360 we have times pi times r squared. And that is our general formula for the area of a sector in degrees. Now let's apply the same idea to arc lengths. Now, the circumference of a circle is 2 pi times the radius. So that's all the way around. So how much do we have here? We have 1/4 of the circle. So this is going to be 1/4 of 2 pi times 10, which is going to give us 5 pi. So applying the same idea to circumference that we did to area, what is the length of this blue arc in terms of x degrees and r radius? Well, the length is going to be x out of 360, that's how much of the circle we're looking at, times 2 pi r. And 2 goes into 360 180 times, so we can write this as x over 180 times pi times r. And that is the general formula for the arc length. So let's apply this to an example. We have a circle of radius 3. So let me get my circle here. And it has a radius of 3. Oh, that's kind of funny looking circle, isn't it? Come here. Oh well, we'll just go with it. And the angle in between is 50. So the length of the arc is going to be 50 over 180 times pi times r. And that works out to 150 over 180 pi, which will reduce to 15/18, which further reduces to 5/6 pi. And that's in centimeters. So it's 5/6 pi centimeters along, that little bit right there. Okay, now what's the area of the sector? That's this area, this pi slice. All right, so the area is going to be 50 out of 360 times pi times r squared, which reduces to, that's going to be 9 times 50 is 450 out of 360 pi. And I can cancel the 10s out there. And then I can have 45 over 36, which works out to 5/6 pi square centimeters. Notice that it's not centimeters, it's area, so it's square centimeters. And I made a mistake, didn't I? That's not 5/6, that's 5/4 pi centimeters squared. All right, now this is the another example, and here we're going to just try and find this green area. And the way we're going to do that is we're going to do the green area is equal to the sector area minus the triangle area. In other words, this triangle right here. Okay? Now the sector area is pretty easy. So the sector area is going to be 120 out of 360 times pi times 36. Okay, and 36, that cancels, and that's 10. So I get 120 over 10, which is 12 pi. All right, how about the triangular area? Well, this is also 120, the central angle, and if I draw an altitude right there, it's going to split this up into 60, and that's 90, and that's going to be 30. And so this is going to be the short leg, which will make this half the hypotenuse. That'll be 3. This is going to be the long leg. That's going to be 3 square root of 3. And so the entire base of my triangle is 6 root 3. So the area of the triangle is 1/2 the base times the height, which is 3 right here. Okay, so that is equal to 9 root 3. So here we go. Our green area is going to be the area of the sector minus the area of the triangle. And that's the way you're going to leave your answer, just like that.